A digital input card kept throwing nuisance faults. No pattern anyone could see, no consistent point, nothing showing on the trend that explained it. Most of this series so far has been building logic from scratch. This one's different. This is a real fault I traced, start to finish, and the fix wasn't in the ladder at all.
We've got a DI fault on card 3.
Here's what we were seeing. A digital input card would occasionally flag a fault on one of its points, sometimes 0.3, sometimes 0.5, no consistency. The equipment tied to that input hadn't actually changed state, a limit switch reading, open, when it was physically closed, that kind of thing. It would clear on its own within a scan or two, so production barely noticed, but it kept showing up in the alarm history, and often enough that operators started ignoring defaults altogether, which is its own problem. First troubleshooting instinct for a lot of technicians is to suspect the card itself, maybe it's failing, swap it out. We did that early on. Fault kept happening on the replacement card too. So it wasn't the card. Once the card was ruled out, we went through the usual suspects. Wiring terminals, checked and tight, no corrosion. Field device itself, the limit switch was mechanically sound, no intermittent contact issue we could find with a meter. At this point I started asking a different question, not, what's wrong with this input, but, what else is happening on this panel at the exact moments these faults occur? That's really the shift in thinking this case study is about. Sometimes the fault isn't in the circuit you're staring at, it's coming from somewhere else entirely, coupling in. So I pulled the fault timestamps and started cross-referencing them against everything else logged around the same panel, motor starts, motor stops, any other switching event. And there it was, nearly every default lined up, within a second or two, with a motor start event on a contactor sharing the same panel. Not every motor start caused a fault, but every fault had a motor start near it. That's the pattern that pointed toward electrical noise, specifically, the transient generated by a contactor closing under load, on aging contacts, without any suppression across them. Here's the mechanism. When an aging contactor closes or opens under load, there's a brief arc across the contacts. That arc throws off a fast electrical transient, a spike of electrical noise. If that noisy wiring runs in the same cable tray or conduit as your D-signal wiring, especially over any real distance in parallel, that transient can capacitively couple into the D circuit, inducing a brief false voltage on the input line. The PLC's digital input card reads that induced spike is a real signal change. It's real electrically, just not real from the field device. The card did exactly what it's supposed to do, it just got fed bad information for a few milliseconds. This is a classic electrical noise problem, and it's common enough in cement plants with a lot of motor starters sharing panel space and cable routing with instrumentation wiring. Two things fixed it, and honestly both were worth doing together. First, the electrical fix. We added an RC snubber, a resistor-capacitor suppression network, across the contactor coil terminals. That gives the arc energy somewhere to dissipate instead of radiating out as noise. This is the real fix, addressing the actual source. Second, a software-side safety net. We increased the input filter time on that D card's channel, the debounce setting, in Studio 5000. A few extra milliseconds of filtering means a transient spike that lasts only a couple milliseconds gets ignored, while a genuine, sustained field signal change still comes through fine. I want to be clear about the order here. The snubber is the actual fix, addressing where the noise comes from. The filter time adjustment is a safety margin, not a substitute. If you only adjust the filter and ignore the noise source, you're just raising the threshold for the same underlying problem, and a stronger transient down the road can still get through. The broader lesson here, beyond this one fault, when something looks intermittent and doesn't correlate with the thing it's supposedly monitoring, start looking at what else shares its physical space. Same panel, same tray, same conduit run. Electrical noise doesn't respect the boundaries we draw on a schematic. And always fix the source before you paper over the symptom with a filter or a timer. A filter buys you margin, it doesn't solve the actual problem. Quick recap. Symptom: intermittent defaults with no consistent pattern. Root cause: contactor arcing inducing a noise transient into nearby dewiring. Fix: RC snubber at the source, plus a modest input filter increases a safety margin. Next video, we'll cover a related skill, how to safely force I/O for troubleshooting, and when forcing crosses the line into dangerous territory. That's a skill every technician needs, but one that gets misused more often than people admit. Subscribe so you don't miss it.